So our second type of conic is going to be a hyperbola. And if you remember, the ellipse was defined by two fixed points, and the sum of the distance between those two fixed points was going to be constant. Here for hyperbola, it's going to be opposite. So a hyperbola is the set of all points in a plane such that the absolute value of the difference between 2 points is constant. So if these are my two fixed points, if I look at the distance from one point to another, the difference between these two is constant no matter what I pick. But you can see one side is bigger than the other, so we just care about the absolute value. We don't care whether that distance is positive or negative, or that sum is positive or negative. So our formula looks really similar to an ellipse, but instead of having a plus in the middle, we're going to have a minus. So we have two possible equations for our hyperbolas. We have x squared minus y squared equals 1. And then again, these numbers underneath x and y are going to be an indication of how far you go out in a certain direction. But the other case here could be that the y term is positive, okay? And this, it really won't make a difference which one you pick to be a and b. So I'm just gonna stay consistent. The thing that's under y is going to be b, because this is really helpful for when we talk about the asymptotes. But the main idea is whichever one is positive tells you the direction that the hyperbola opens in. So if the x is positive, the hyperbola is going to open in the x direction. When the y is positive, it's going to open in the y direction. And then again, we're going to move these things off of the origin being our center. So in this case, when it's just x and y, your center point is smack dab in the middle. Okay. Then that number underneath is going to tell you how far you move in that particular direction. But here it's not like an ellipse where I need to go out in each direction to get that set of points. I really just need to go out the distance in the way that the hyperbola is going to open. So in this case, since I open in the x direction, I'm going to go out a distance of a. So this point here would be a0, and this point back here would be negative a0. And then your hyperbola is basically going to be comprised of almost two parabolas. Okay. So the idea is these two fixed points are actually going to occur inside. So your conic is always going to wrap around your foci. In the case of an ellipse, your two foci were on the inside, and again, you're wrapping around it. Here, because the hyperbola is going to open in this direction, you're wrapping around, but it has to go in opposite directions. So the idea is if I take this point here and I look at the distance between those two foci, but then I take a different point here and look at the difference between that point and the two foci, that should be constant. Okay. These points are still going to deal with some value of c. So in this case, this would be c0 and negative c0. Now, this is still going to be important for us. It just doesn't give us anything important of how far you move in the y direction. What happens is we actually have two different asymptotes. So your curve always hugs an asymptote. So there are going to be two lines here that your hyperbola hugs. So let's go ahead and turn these a little bit smaller and make them dashed lines. Okay. The equations of these lines are going to deal with the numbers underneath. And again, that square just happens because of the distances. So this one goes right through the center. So it's got the form y equals mx. The y-intercept is 0. So the slope of it is going to be the value under y divided by the value under x. So So that's just like your normal slope. It's the difference in y's over difference in x's. So you take the thing under y and divide it by the thing under x. And then your other asymptote is just pointing in the opposite direction. So it's negative b over a. Okay. So what happens is this axis is the one that all of the important information lies on because the x is positive. That axis is called the transverse axis. So here the transverse axis is in the x direction. Specifically here, it's along the x-axis. But again, if you move it up and down, then it's going to be a different equation that would be a horizontal line. When your y squared is positive, the only difference is now it's going to open along the y-axis. So I would move up and down a distance of b because that's what's underneath y. So this would be the point 0, b, and this one would be 0, negative b. Then you have your foci, which is what our graph is going to wrap around. And same thing, this will be some c value. And then we have our two different asymptotes that we end up hugging. And again, let's go ahead and make these dotted and a little bit thinner. And then our graph is going to wrap around those foci and hug the asymptotes. Okay. The equations of our asymptotes are going to be exactly the same because the roles don't switch. Here you would have positive b over a, and here you have negative b over a. So with these, the positive variable tells you which way the hyperbola opens. And then the slope of the asymptotes you can think of as y over x, which is just like the slope of the line. And then in both of these cases, that center is going to be at 0, 0. Okay. In order to find the foci, or that value of c to get you out to the foci, here we're going to be able to directly use the Pythagorean theorem. So to find the foci, you're going to use c squared equals a squared plus b squared, which is why it really makes zero difference what you label a and b, because here you just add those two values together. I don't have to worry about subtraction and one being bigger than the other. Okay. So when I shift this, the same idea happens with ellipses. We just move everything by what we've shifted. So for this example, we're going to find the center, the transverse axis, the vertices, the foci, the asymptotes, the domain, the range, and we're going to go ahead and graph it. So this is the equation of my hyperbola. Again, that minus immediately tells me it's a hyperbola, but I always need a 1 on this side. So just rewriting this, that's y squared over 9, and then here you get x squared and 1. So that really tells me what's underneath x is 1. Okay. So we're going to start by graphing this thing because that's going to help us then figure out all of these key pieces of information. That center is at 0, 0 because I have just x squared and just y squared. It is just like a normal circle. So I'm going to go ahead and go out 5 in each direction. So my center is right here at 0, 0. So I can fill that in. Then my y squared is positive, so that tells me it's going to open along the y-axis. So my transverse axis is the y-axis. Okay. Now I want to go ahead and start finding some other key pieces of information. So again, because it opens along the y, that tells me how far from the center I move to find my vertices. So in that case, I move a distance of 3, because the square root of 9 is 3. So I go up and down 3 to get those vertices. So those will occur at 0, 3, and 0, -3. Okay. Then I can also go ahead and find my foci. So in this case, again, I need to find c, but c squared is a squared plus b squared. And again, it makes no difference what the labeling is. You just go ahead and add the two numbers under x and y. So c squared is 10, which means our value of c is root 10. I don't have to worry about the plus or minus because the c is a distance. So my foci, square root of 10 is like 3 point something. That foci would be somewhere right around here. And then likewise down here. So in that case, this whole distance is our value of c. So one foci will occur at 0, root 10, and the other foci occurs at 0, -root 10. Okay. Now I also need to find my asymptotes. So I know those have the equation where y is equal to positive b over a x, and then you have the negative version of that. So really what you can do is you can put a plus or minus in front. So in this case, again, I look at what's underneath y because that goes in the numerator of slope. So in the top, we're going to have 3. And then I look at what's underneath x to figure out what goes in the bottom because it's difference in y values over difference in x values for slope. So we get a 1 underneath. So one equation would be y equals positive 3x. The other equation is y equals negative 3x. And you don't need the full equation to actually graph it. Just from that center point, you can use these to find another point on your asymptote. So I would go up a distance of 3 and then right a distance of 1. So 1, 2, 3 over 1. That gives me a point on my asymptote right here. And then we just go ahead and connect those dots. And then again, let's go ahead and make this a little bit smaller and dashed. So this would be y equals positive 3x. Then I do the opposite. I go down 3 and then to the right 1. So a point on my other asymptote would be right here. So going through and connecting those dots as best as we can. If my pen wants to work, here we go. And again, going ahead and making this a little bit thinner and dashed. That will be the other line, which is negative 3x. Then to graph, I go ahead and I just hug my asymptotes and I go through those vertices. So that would be our graph of this hyperbola. Okay. Now I want to get the domain and the range, and thankfully domain is x values. We go up, or we go to the left and right forever. So our domain here is all real numbers. The range is a little bit harder because I don't take on these values in between. So really I have one piece which goes from 3 to infinity. And then I have another piece which is negative 3 down to negative infinity. So in interval notation, that would be negative infinity to negative 3. And we do equal negative 3 because we have a point right there. And then our next piece starts at 3 and goes to positive infinity. Okay. So there is our hyperbola and all of our key pieces of information. So let's try a different type of example now where we want to find the equation given the key pieces of information. So here I don't know everything going on. I have to figure out not only which one's the positive quantity, which one's going to be negative in my formula. I need to reverse engineer what goes under each. So always a great idea to go ahead and graph these just because you'll get more information. So I know where my vertices are, and they also give us an asymptote. So let's go ahead and graph that. My vertices occur in the x direction. So I'm going to go out, let's do 4, 5 in each direction. So starting with my vertices, those occur at -4, 0, and 4, 0. So immediately this tells me this opens in the x direction. So with that, I know the form, the x term is the one that's going to be positive. So it's going to be x squared minus y squared equals 1. And then I'm going to need some number under x and then some number under y. Okay. But I do know the value that's under x because that's going to be the distance from the center to that particular point. So my center in this case has to occur exactly halfway in between my vertices. So that's a distance of 4, that's a distance of 4. Really, this immediately tells me my value of a is going to be 4. So I can fill that in. I know this is going to be x squared over 16 minus y squared over b squared equals 1. Okay. Now I need to figure out this value of b, but I haven't gone through and plotted my asymptote yet. Because that is one of my asymptotes, and I can immediately figure out what my other asymptote is going to be. This won't work, unfortunately, if we have a shifted center, but at least because the center is at the origin, these are going to be symmetric. So my other asymptote is going to be positive 2x, okay? So going through and graphing that, that would give me a slope of 2 over 1, which would put me right here. Then you could go down 2 over 1. So that asymptote would look like this. And then for the other, we go down 2 to the right one to get a point, and then you could do the reverse back up here. So plotting that looks like this. And then again, from here, you really could go ahead and graph this thing. You'd end up hugging those asymptotes. So this hyperbola would look something like this, okay? All I have to do is figure out what goes underneath B. And really that's where we're going to use this slope. So we're going to use the asymptotes to find B. Okay. So I know that ratio, B is underneath Y, A is underneath X. This needs to equal 2. Okay. Well, I know my value of A, so B over 4 needs to equal 2, which then immediately tells me my value of B is going to be 8. So that's what goes underneath my Y value. I just have to square it. So our equation of this hyperbola is going to be x squared over 16 equals y squared, minus y squared over 64 equals 1. So that is our hyperbola. Okay. So it's really nice when we do have the center at the origin. All that happens when I move the center to a different position is just like with a circle, all of your x's get replaced by x minus h, and all of your y's get replaced by y minus k. So I'll go through the formulas for if it opens in the x direction, and then we'll do an example with that. But the same idea is going to hold if it opens in the y direction. You just start from that center point and move those distances you need to. All of the key pieces still stay exactly the same. So in this case, my x is going to be the positive quantity. So my center here is going to occur at HK. So I'm just going to pick a random center. Let's say that happens to be right here. This will be HK. Okay. We are going to open in the x direction. And specifically, this is going to be a horizontal line. So my transverse axis would be the line through that center that is horizontal. So that would be the equation y equals k. That's how we get a horizontal line. So it goes through that center and opens in the x direction. If it was the y term that was positive, well then that transverse axis would be vertical, and that would be the equation x equals h. To find my vertices, I start at that center, and I only am going to move in the x direction, a distance of a. So I'll go to the right a distance of a, and what that does is it adds a in the x coordinate. Then we go back a distance of a, so in that case we would subtract a from the x coordinate. And then we'd have our hyperbola doing something like this. Okay. So my vertices will occur at h plus a, k, and h minus a, k. So the y coordinate is untouched. So if it's the opposite again, then you just do whatever you move in y's direction, add and subtract that from your center point. We'll move on to the foci next, because again, those occur in that same line. So one foci would be in here, the other foci would be in here. So in that case, the distance out to here would be c. So starting from that center coordinate, we'd add c, and then we'd also subtract c to get the other point, okay? I'm going to avoid filling in the graph so it's not so muddied. But again, you can also just write these condensed as plus and minus. So you add and subtract that distance. When we talk about the asymptotes, we still use the same idea. So I have one asymptote through the center, the other asymptote through the center. And then let's go ahead and make these a little thinner and dotted. Okay. So in this case, our normal equation is y equals plus or minus b over a times x. You don't have symmetry anymore because you can see we have two different y-intercepts now. So you're going to have to find these each individually. But you just replace y by y minus k and x by x minus h. So our equations are going to be y minus k is equal to plus or minus whatever's under y over what's under x. And then we replace x by x minus h. Okay. So for this last example, we want to find the center, vertices, foci, asymptotes, transverse axis, domain, range, and we want to graph it. The problem with this is it is definitely not in standard form that I can immediately pick off what the center is and what is underneath my x and what's underneath y. However, I do know that it's a hyperbola because I have one positive term and one negative term. So just like with a circle, in order to be able to put this in standard form, I have to complete the square. So I'm going to group my x's, group my y's, and then move my constant term to the other side. So grouping the x's, we have 4x squared minus 24x. Then we have minus y squared minus 4y. And then when I move the constant to the other side, I get negative 16. In order to complete the square, I need to have a positive 1 in front of each of these terms. So for the x, I have to factor out a 4. That leaves me with x squared minus 6x. And then here we factor out a minus sign, which gives us y squared plus 4y. Okay. Then I need to figure out what to add to make this a perfect square. So I take this number and divide it by 2. So that middle term has the negative 6. Negative 6 divided by 2 is negative 3. But then I square it, so I'm going to add a 9 in here. The problem is I don't just add a 9 to this side, because really what happens is this 4 would distribute back to everything. So over on this side, I really have to add a 4 times 9. So again, if I were to distribute the 4 in front, that's 4x squared minus 24x, and that would be plus 36. So we really need to add plus 36 over here. And then likewise, when I go to figure out what to complete the square with on y terms, the middle term is 4y. When I divide that by 2, that's 2. When I square that, that gives me a 4. Again, I don't just add a 4 to this side. What happens is that minus out front distributes back. So really what I've added on the left is negative 4. So I need to add negative 4 on the right-hand side. So that gives me 4. Now the x's I can factor as x minus 3 squared. The y's I can factor as y plus 2 squared. And then on the right-hand side, I have negative 16 plus 36 minus 4. That really gives me 16. But in order to have this hyperbola in standard form, I've got to go through and divide by 16. So that leaves me with x minus 3 squared over 4 minus y plus 2 squared over 16 equals 1. Okay. So this is fantastic. I now can go through and I can find my key pieces. I know my center now is going to be positive 3 and negative 2, so that's great. And then I'm going to need to figure out my vertices, my foci, my transverse axis, my domain, and my range. And I think that's everything I needed to find correct. Okay. So I'm going to go ahead and move this down because I already have a graph kind of pre-drawn in here for me. These are the key things I need to find, and I need to make room for all of this. So let's move this over, move this over here, and then we'll move our equation down here. Okay. So starting with my center at 3, negative 2, that will be right here. Now I want to figure out my vertices, so I'm going to move in the x direction. What's underneath x is 4, so that tells me to go a distance of 2. So going 2 to the right will land me at 5, negative 2. So that's one vertice. And then to get my other one, I go back a distance of 2. That puts me at 1, negative 2. Okay. To find my foci, I have to figure out what my value of C is, which not to confuse with the C I wrote for the center. But we know that C squared is equal to A squared plus B squared. So C squared is going to be 4 plus 16, or 20. So our value of C is the square root of 20, which is like 4 point something. So to find those two foci, I start at that center point and I add a distance of root 20. And then I also subtract a difference of root 20. So we can just go ahead and write that as one thing. Root 20 again is about 4, so 1, 2, 3, 4 here, and it's a little bit past that, so one foci is here. The other foci would be 1, 2, 3, 4, and a little bit, so somewhere right around here. Okay. My transverse axis is going to be a horizontal line, and it's the one that goes through the center. So the equation of that would be y equals -2. Okay. Oh, I also need to find the asymptotes. I did not write that down as something I need to find, but not a problem. We will go through and do that as well. Okay. Now I can get a decent graph from here, but again, I want to find those equations of the asymptotes fully, but at least I can utilize these with my slope to figure out what that looks like on the graph. Then we'll go through and find our actual formula. But starting from the center, my y, which is my rise, will be 4. My run will be 2. So in this case, I would go up 4, which would be 1, 2, 3, 4. And then my run is 2. So another point on my asymptote will be right here through 5, 2. And that gives me 1 asymptote. So you can get a rough idea for what the equation is, but again, we are going to go through it. Then the other one just has a negative slope, so you can go down and to the right, or you can go up and then backwards to get another point here through 1, 2. And then we go ahead and draw that line. Now I want to go ahead and make these dotted or dashed. Those are the equations. And then to get our graph, we are going to wrap around our foci and hug those asymptotes. Okay. We can also write our domain and range now. So our domain, we do not take the values in between those two vertices. So that would be between 1 and 5. So one interval will be from -infinity to 1. And then also from 5 to infinity. So again, these x values are -infinity to 1, and then from 5 onward to infinity. Then we also want the range, but because these hyperbola pieces go up and down forever, the range is really nice. That's -infinity to +infinity. Now I need to get the actual equations of these asymptotes. You could use the center and then use that other point from the slope to find it, because you know the slope is going to be 4/2. Or you can go ahead and use that formula to figure them out. So I'm going to do that down at the bottom because I have a little bit more room. So again, without moving the center, that formula would be plus or minus b/a times x. So the value under y is 16, so the value of b is 4, and then the value of underneath x is 4. So in the denominator will be 2. So again, this is if we didn't move the center, okay? But because I'm moving the center, I need to replace x by x minus the x coordinate of the vertex, which in this case, the x coordinate of the vertex is 3. And then for y, I need to replace y by y minus the y coordinate of the vertex, which in this case is 2. So when I subtract it, it becomes y plus 2. So this breaks off and forms two different equations. One is y plus 2 equals 2 times x minus 3. The other is y plus 2 equals negative 2 times x minus 3. So we want to put this in slope-intercept form. So distributing out the 2 on the first one will be 2x minus 6. And then subtracting 2 gives us the line y equals 2x minus 8. Doing the same thing for the negative slope will give us negative 2x plus 6. And then subtracting 2 gives us negative 2x plus 4. So those are the equations of our two asymptotes, 2x minus 8, and then y equals negative 2x plus 4. You can kind of see that. Again, our picture isn't perfect, but for the negative one, it does look like the y-intercept goes through positive 4. And then this is 5, so 6, 7, 8, roughly about the other y-intercept for that line. Okay. So again, these are all of the key components for this particular hyperbola. If it's, again, shifted so that the y is the positive term, the same idea happens. You just do everything with the y-coordinate. But the asymptotes are still found in exactly the same way.